Alright, today we are reviewing solving systems of equations. Just as a reminder, there are two types of solving systems. You can either do it by elimination or by substitution. We're going to talk about both of those today. The first of these that we will talk about is by elimination. So you see that in the first two boxes or two slides of your notes that it says step 1, step 2, step 3, step 4, step 5. This is all working on this one problem that you see here. So, step 1 is to arrange the equation with like terms. We have x's, y's, the equals, and our constants. So in this particular problem, these have already been arranged in the same column as its like term. So, what we are going to do is we have this equation, and what we are going to do is we want to actually eliminate one of the variables. Oops, excuse me. We want to eliminate either the x or the y. Now we could either do this either way. We could multiply the top equation by -2, and that will result in a -2x that when I add these two will cancel. But there is an easier way in this problem. Notice that both the y's have a 3 in front of them. All we need to do is make one of these y's a -3y, and then they will add to 0. So let's multiply the top one by -1. So when I distribute the -1 to the x, the 3y, and the 7, I will get -x minus 3y equals -7. Notice I didn't multiply the second equation by anything, so I'm going to leave it the way it is. So now that I have it all set up, step 3 says to add the 2. So what I'm going to do is I'm going to add -x plus a 2x gives me a positive 1x. -3y plus a 3y results in a 0y. And then I have the equal sign, so bring that down. And then -7 plus 14 is a positive 7. So we are going to get x equals 7. Now, sometimes we'll have to solve for x, but in this case, we were left with a 1x, so we didn't need to worry about it at all. Now that we have x equals 7, I'm going to go grab one of these original equations. So let's just take this one, and I'm going to paste it right here. Okay, we know that x has to be 7, so I'm going to replace this x with a 7. So 7 plus 3y equals 7, solve for y. So I'm going to subtract 7 from both sides. I get 3y equals 0. Divide by 3, y equals 0. So my solution to this problem is x equals 7 and y equals 0. It is a point. When two lines intersect like this, the point at which they meet is your answer. So your answer is not 7, your answer is not 0, your answer is 7, 0. So what we can do is we can actually take the original equations and plug in 7 and 0 to see if it works. So if I plug in 7 for x and 0 for y, do I get 7? The answer is yes. If I go back and grab the other equation, all right, so there's the other equation, plugging in 7 for x and 0 for y, do I get 14? And 2 times 7 is 14, plus 0 is still 14, so this works. So the solution 7, 0 works for both problems, so that is my answer. All right, taking a look at this problem, I would like for you to try it. Okay, pause and give it a shot. All right, so the step 1 is to arrange the equation with like terms in their columns. Notice that the x column, the y column, the equals to, and the constant are all aligned correctly. So I don't need to continue to do anything with this. So we move on to step 2, multiply one or both of the equations by a number. So let's see, if I were to multiply this second equation by, let's say, -2. What's going to happen is when I multiply this -2 to the 2y, it's going to result in a -4y. So it becomes a negative 2x minus 4y equals a negative 28. If I bring the other equation down, we'll notice right off the bat that these two y terms are going to cancel each other out or add to be 0. So I'm going to go ahead and add the two equations. 3x plus 2x is 1x. 4y plus negative 4y is 0y. Bring down my equals 2, and 10 minus 28 is negative 18. So my x value here is negative 18 for x. I'm going to take one of the original equations. It doesn't really matter which one I choose, as long as I put in negative 18 for x. Alright, so 3 times negative 18 results in a negative 54. So I'm going to add 54 to both sides, and 4y equals 64. In order to get y by itself, I will divide each side by 4, and I get y equals 16. So the answer to this problem is negative 18, 16. If I were to take this problem, and for every x value plug in negative 18, and every y value plug in 16, if I were to do that and plug it into both of these equations, they would work. You should never miss a problem like this. Alright, let's do one more. Notice that these are not currently in the columns. X and y are not like terms, so we need to rearrange. So I'm going to keep the top one, because it's x plus y equals a constant, but I'm going to add 5x to both sides to move this 5x to the other side. So 5x plus 2y equals 12. Alright, so the first thing I'm going to do is I'm going to multiply this whole bottom one by negative 1, because I want this negative 2 here so that when I add them, the y's go away. So the first one stays the same. Negative 5x minus 2y equals negative 12. Don't forget to distribute the negative 1 to each term, including the 12. A lot of people will forget that. So now we're going to add our 2. So 3x plus a negative 5x is a negative 2x. 2y plus a negative 2y is 0. Bring down my equals. 8 plus negative 12 is negative 4. So in the other problems, we had been left with x equals a number, but now we have a negative 2x equals negative 4. So we need to divide both sides by negative 2, and we'll get the value x equals 2. So first part of our solution is 2 comma. So now we need to find the next solution. So we're going to take x equals 2 and plug it into one of the original equations. So I chose the first equation, 3x plus 2y equals 8. Instead of x, we now know that x should be a 2, so we're going to plug in a 2 for x. 6 plus 2y equals 8. Subtract 6 from both sides. I get 2y equals 2, which means y equals 1 because you have to divide both sides by 2. So my answer here is the point 2 comma 1. You remember that you can plug it back in to both equations and verify that you did this correctly. Now we're not going to completely solve these problems, but I do want to talk really quickly about these two types of problems. First off, with number 2, notice that the x's will automatically cancel each other out when I add. So we'll get 7y equals 0. We had to skip step 2 because we already have something that is going to cancel out. No need to multiply. For number 1, this is a little bit trickier because we're actually going to need to multiply both equations. I would multiply the top by 4 and the bottom by 3. And here's why. The first equation will result in a 12x plus 15y equals 24. And the second equation will be negative 12x plus 6y equals 15. Because I multiplied each equation, I now have two x's that will add to 0. 12x plus a negative 12x. Okay? Oops, and I messed up there. That wasn't 15, was it? It was 20. 4 times 5 is 20y. So I would end up with 26y equals 39, and then we could solve for y, plug it back in to get x. in case you did, that's 1.5, excuse me, in case you did problem number 2, just to make sure you were right, the answer here is actually 0, 0. Alright, so the next thing we're going to talk about is substitution. Okay, in the substitution, the first equation, or one of the equations, must be set equal to either x or y. And the reason for that is I'm going to take what x equals, which is 2y plus 9, and plug it into the second equation where the x is. So step 1 has already been done for us. But now I'm going to take this 2y plus 9 and plug it in for x. Be careful when you do this because you're actually going to need a parentheses. The reason you need the parentheses is because you need to remember to distribute the 2 that was in front of the x to each term. So let's solve for y. 4y plus 18. Okay, that's the distributive property. Bring down your plus y equals 42. I need to combine the 4y and the 1y, so this will be 5y plus 18 equals 42. Subtract 18. Oops, I'm running out of room here. 5y is equal to, okay, divide by 5, oops, and I get y equals 24 over 5, or I would allow the decimal 4.8 because it ends, it's not repeating. So now that we have y as 4.8, we're going to do exactly the same thing. We're going to take one of the previous equations, let's say x equals 2y plus 9, but instead of plugging in y, we're now going to plug in the 4.8 that we found y to be. So 2 times 4.8 plus 9 means that the x value is 18.6. So my solution is 18.6, comma 4.8. Again, you can check this answer to make sure you did it correctly. Okay, here's another problem. Notice that it is currently not set equal to either x or y, so we need to do so. First thing I would notice is that there's no number in front of x. It makes my life a lot easier. So we'll take this second equation and solve for x. If I subtract 2y, I get negative x equals 100 minus 2y. I also want to divide this x by a negative 1 to get the negative off of it. And what I do to one side, I do to the other. So this is actually going to change the sign of the negative 2y to a positive 2y, and the positive 100 to a negative 100. So now that we know that x equals 2y minus 100, we are actually going to plug that in into the other equation. So it's going to be 3 times 2y minus 100 equals 21y minus 5. Now it's our job to solve for y. So distribute the 3 in to make 6y minus 300. We're going to subtract 6y from both sides. I get negative 300 equals 21 minus 6 is 15y. And then we're going to add 5 to both sides, so negative 295 equals 15y. We're going to have to divide both sides by 15, and we'll end up with the fraction negative 59 thirds. Now I don't want this as a decimal, because what's going to happen is you're going to get 19.66666 repeating, so we would have to round, and when we round, we change the value of the number. So leave it as a fraction in this case. Now that we know y equals negative 59 thirds, we can plug it back into the original equation. So 3x equals 21, and then y is negative 59 thirds minus 5. So I took the original equation, 3x equals 21y minus 5. So let's plug it in and find out what we get. All right, so you should get negative 418 thirds over, and negative 59 thirds. Now we're not going to have time to completely do all of this problem, so what I'd like to do is just discuss how we would set this equal to eliminate so that we just have y equals. Both of these equations are really tricky to work with, so what we need to do is actually just pick one that already has y here alone and divide everything by 2. So you're going to get y equals 6 minus 5/2 x. And then we can plug it in and work with the fraction from there. So what you see here is when we plug this in 4y, we actually end up working out very nicely and ending up with a nice, pretty number, 2, 1.